So today we are talking about, me and Tristan, we're talking about how do we get a new OS like NixOS instead of all the old distro, and run on the new open architecture RISC-V, and the progress and the vision we're going to put it down, and hopefully, and the road ahead of us, and what we're going to be on the AI ages. So, myself, I'm Liang, and then I'm sorry, I'm a software guy, and I used to port all the virtual machine onto all the hardware, from the old Power, MIPS, and ARM, and x86, and all different versions of ARM. And also a compiler guy. I founded the DeepComputing during the COVID. I sold my compiler or security company with money, nothing better to do, and then I found a hardware company. So that means that I'm going to lose a lot of money. So, and I blame who? I blame two guys. One is Steve Jobs, in one of the keynotes, says that we quote Allen Key. Whoever serious about software, we got to make our own hardware. You know why? Because the hardware guy doesn't listen to us. All right. So, anyone knows about RISC-V? Wow, man, 80% of people. Good. So basically, ISA is just an ISA. It's just a software controlling the hardware, telling what to do. We call it instructions. And then what is different from ARM? ARM says, I only want to put the instructions I want it, not you want it. So RISC-V is saying that you feel free to do whatever you like, as long as you know what you're doing. Right? It's not like Dave saying that we need to put some protobuf instruction into the SoC so that Google runs things very efficiently, because the whole Google using the switch or protobuf. Right? So that's one of the examples. And the other example is open. Open means what? Open means belongs to whoever understands. It doesn't belong to China, doesn't belong to Iran, doesn't belong to US, doesn't belong to anyone that don't understand it, but it really belongs to whoever understands it. So exactly the same as Linux. Exactly the same as Linux. If you understand it, that's yours. If you don't understand, just be your garbage, right? So what happened to it? I'm sure that once it open up, once people understand it, people are going to teach about it. And exactly the same as Linux. Back in my university just now, the host says that back in the 90s, we learned Linux from school, right? Because the school can't teach body Windows, isn't it? So I'm sure it's going to live forever because people teaching it. It's founded in 2010. It's 15 years old. It's pretty old, actually, right? But it makes very good progress. So what is the prospect of it? It basically, I was saying that the dream is very, very big enough. I would say it really analogy to Linux. So Linux now actually is really big. It occupies the whole server market. It occupies all the mobile market. The only thing you left is the desktop you guys using, right? So actually, I would say is Linux is occupy 60% of the market. But what I'm trying to do is that for RISC-V, we just be fair enough. One day we are hardware-wise competitive. Okay, we just want 1/3 of the market. Right? That is our dream. Actually, it's still quite big. So like 1/3 of you guys, wow, a lot of guys using framework, open modular, and then yes. And you know why open is important, right? And you learn so much thing from it. And 1/3 of you guys using RISC-V. And now I hope the whole next community, 1/3, we're going to first community, 1/3 of them using RISC-V. Then I will solve Ron's problem of the foundation and raising money. Anyone you guys buy RISC-V as the Next community member, we donate back the profit to the foundations. So keep the community going, right? So that is the mission to do by being open. So you can see it's serious, man. You think the young kid here, one day, 30, 20, I would say 5, 10 years later, you can be as good as all these big boys. Just same as I'm good friend of Greg KH. He is a Linux fellow. Do you know what his first job is? He's just a USB driver guy, just out of school. So 30 years later, when you monopoly of the best of the market, then you rise up because you learn so much thing from the open world. So that exactly is as RISC-V. Same as me. I'm software guy. I learn to make motherboard. I learn to make PCB board. I learn to make CAD. I learn to make CPU. I learn everything so much because it's open. And for the past 15 years, you can see it actually grows a lot. And from this year onward, even bigger, from the software side all the way to hardware side. So if you guys have time, go over to our RISC-V booth with one of the RISC-V organization international. One is the community booth to show you all the crazy hardwares. So when before me earn all my money in software, so I had no idea what RISC-V is all about. Why it happens. So and then by the time now I spent 5 years, and we set up the visions that we got to be, because it's openness. So it's just like marrying another partner like Linux. It's open. So we designed the vision. First thing is that we're the best Linux ISA. So how are we going to achieve that? So it has to be open source completely. For example, we're making the server board going to be using OpenBMC. And the bootloader switch from U-boot to EDK2. And then we support the ACPI so that all the OS generic image run on any of the hardware or RISC-V, either through virtualization or through natively, bare metal. And then the most important one is we do pre-silicon upstreaming. That means that before we will upstream our kernel support, even before the chip getting onto the board. So you guys can play on our FPGA emulator to see how it's done, and even the evaluation board, and before you see in the market. So this one, this means that we are determined to do better than ours. And hopefully we do better than even x86. But because we have no technical debt, OpenBMC, we haven't done it before. So it's first one, so there's no debt. Unlike x86, you had to marry of Finis, AMI, all these old BIOS, right? And then, and or whatever, the closed BMC. And EKD2 basically it's just like RISC-V's BIOS, Linux BIOS. And then ACPI is inherit from x86. And the last but not least, do you remember what is the most Linux complaining about in terms of hardware driver? Right? Do you remember the two fingers? Is it this side or that side? Right? So it's very different meaning, this side and that side, okay? And lucky that RISC-V have these two. So we should announce we're going to do an open GPU. And it will be the best usable GPU for Linux. And that is based on RISC-V. It might not be performed as NVIDIA or AMD, but it's good enough for all of us using the laptop and on Linux. And we don't need to ask people for pity driver, right? That is the thing we decided to do. That's the vision of it. And then last year, I have a fun experience. So I made the motherboard, first motherboard, and then that was based on Debian. We changed the shit nodes because at that time, Debian doesn't support RISC-V yet. We hacked around. And then after Debian announced that there is the first, I think it's Debian 10 or 11, say officially support RISC-V. And then flow to Ubuntu. Ubuntu will support it because it's Debian base. And then after that, Fedora jumps in. Yeah, we can do a remix. And then last year, Red Hat rolled out a dev preview for RISC-V. So people actually do play around it and support it. And last year, sorry, I'm just nobody, even I'm a software guy. And NixOS is so new that a 50 years old man had no clue about another OS. And then my God say, and then I got my friend, I think in Ron's, whoever contribute more to the sponsor, Nix, is called ExpressVPN. It's a very a big VPN company. And their CTO is my friend, asking me, I'm Zurich. I said, why are you in Zurich? I'm on an OS conference. What OS conference? And said, NixOS. I said, what NixOS? You lick another OS? So then I just drove all the way down with my two kids, all the way down to see another crazy people. And very funny enough, just come to scale, we suddenly set up one more motto from me. And we discussed with Tristan, said that hopefully this last OS going to solve all the RISC-V problem in the AI era. And we will hope that we're going to prove that from this year onward. So this is the world we say it in at PlanetNix 2026 today. So we will net the time proof whether we're going to do it. So, but that is the NixOS, the first port onto this AI PC. And there's a lot of problems. And then I will hand it over to, we call it Ross, computer guy. So you know him more than I do. So over to you. So you can talk about all the problem you meet and why is that?
Yeah, so basically, this laptop is a little bit different when it comes to RISC-V. Particularly, it has two domains, so it has actually two dies on one SoC, and that plays a little bit of differences in the architecture of how this chip works. And when porting things over, things are a little bit different. So you still have things like the kernel, you still have U-boot, but then you also have some extra firmware, like, I forget what it's called, but I believe it's the SEC boot firmware.
You get as many as you like because it's the halfway open source.
Yeah, and so basically, Union has provided a kernel that is usable for this system. Unfortunately, vendor kernels are a little bit different, because a lot of the silicon takes forever to produce. What happens is you have a kernel from about 2020 or 2023, and they often don't have enough changes that modern mainline Linux does. So like some of the problems is you will have assembly inside of the kernel that is incompatible because they decided to use an unratified version of the RISC-V vector specification. So then the solution is to either find their pre-built GCC, which is also a snapshot from about 5 years ago, or the other solution is just patch everything, which I've actually found patch everything is the better solution, especially when compiling not on x86, because a lot of these vendors compile on x86. So that is one of the problems. And then once it's patched, I was able to at least get it booting. And in that screenshot, you can see I at least got NeoVim, which if you have NeoVim, you at least have Nix. And from there, I've been trying to get some of the other parts of the system working, like the GPU, but also that is a complicated subsystem for hardware.
So basically, it's awful port. Very awful. I can summarize just now what Tristan says. There's two stupid problems of all the hardware we have. It's vendor kernel. We inherit the habit that how do we do OS support for a chipset from ARM. So the way we do kernel is that for this particular chipset is that we pick the LTS and then do massive change on it. And then make sure, because our chipset guy is scared. If I pick the main 9 already a buggy. And then you put more things, even more buggy. Right? And then your boss will ask you where you are. I have no idea where you are because I have no idea what main 9 is. All right? So the driver guy is just panicking. So usually they go for LTS, right? There's vendor kernel. This one, the first one, this port on the first kernel is 6.1. And I forced the chipset guy to upgrade to 6.6. It's a massive work. But, you know, Nix is such a weird thing before, to me. It probably very similar to Arch Linux. Everything's latest, whatever. Or there's the stable release. Probably they have a stable kernel version, right? And our vendor kernel version never matched it up. And the worst thing is, Tristan said that we do have a proprietary compiler. And proprietary compiler have what? You have a vectorized different version, a customer instruction. We talk about the flexibility. So your proprietary compiler. But you think about what NixOS is reproducible. That means you have to use one damn version, right? Or traceable version of toolchain. Otherwise, you compile.
Okay, proprietary compiler meaning it's GCC that you have.
Yes.
Yes.
Well done. GCC that we hack. LLVM that we hack. And then for that particular chipset. So all these things will cause this guy go bananas when they compile 10,000 package. Because some of the package might might support certain version compiler, not supported data, endless, just endless. So once he start doing it, he's sending all the issue I read in there. I think that means I know that the vision we talked about before for Linux, I had to fix that. I had to fix that so that NixOS can build and can achieve its reproducible characteristic on it. So that's why I think tomorrow I talk about pre-silicon kernel upstreaming. That means that at least I will guarantee I can build I would say NixOS's toolchain can build the binary, can run on my chipset. Even I had to sacrifice some of the customized hardware features. So that's never done before. All the SoC guys have their own weird compiler versions. I give you an example because the ARM, the way all the guy doing RISC-V SoC is all from ARM ecosystem. So the ARM, they build a chipset, build an Android for it. Android have 6 versions LVM. That's how it works, right? So all the people just love to hack around toolchains. So, but on RISC-V, you can't do it anymore because we decided we had to support the UOS. That's why we gradually sorted out the pre-silicon kernel upstreaming. That result Nix can build the whole package later on and get better. And then the other thing, we talk about the proprietary hardware called GPU, right? That's why he says, oh my God, that GPU drivers only support certain kernel version. I bet you guys experience it, right? even CUDA or whatever, you only support a certain version of it. And you never be able to support latest version. So that's the why I had to this year have two objectives. I think pre-silicon kernel upstreaming, we're getting there. So you can see the latest RISC-V 16 core RISC-V SoC, and you can build mainline kernel we can run. So that is a big major step forward, better than now. And the other thing, second half of the year, I will open up a Linux Foundation project. We decided to do GPU. So that is a massive change for us to support better open source OS. So what happened is that after we do the AI PC, all the painful stuff, then this year, basically, I think I would foresee that we at least we can support NixOS on our 16 core machine that we're using non-GPU rendering. For example, LVM Pi. And that will get NixOS stable version can run on RISC-V first forever. And then you can see we have this year we have a lot of AI machine coming out. So from framework, and then from Tenstorrent, and then a lot of heavy compute coming out. So that is the reason that we are moving on to the whole orchestra of AI. And we're moving to NixOS. Because so far, Red Hat and Ubuntu, I don't think they are doing good enough onto the AI orchestra, model as service, infrastructures. That is the thing that I think NixOS have the advantage. As today, you don't announce how NVIDIA CUDA run on NixOS. And there will be more. For example, like Tenstorrent stack, I think Tristan is working on this as well. So probably we can do a lot more on the whole AI stuff and make sure we achieve completely open. Like Tenstorrent's AI stack is completely open. Anyone can change it, anyone can fix things. And then the other thing is reproducible, so everything's consistent. Otherwise, we don't even know the model is running correctly or not, by what, right? And then it's flexible enough. Like us, we're a very small company, and we can still make AI compute, RISC-V compute, and 1/10 of the cost to RISC-V, but to NVIDIA or market price, with all the open accelerators. So that is the future that the world ahead of us for this year. And then NixOS hardware team gonna have a lot of work and helping us to get the first version out, and probably including Flox is the open source version of the AI support. So I think you guys definitely can contribute on that. And once we get it going with certain models, open source model or closed source model, and I'm sure that we have a lot of free credit for you guys to pay around to improve Linux even more. Thank you. That's all from me. You have anything to add? Good. Good. Thank you. Any question? Any question that you guys want?
Yeah, so GPU, is this all gonna be built on 10 voice technology they're relying? You can obviously give more PETA, that's fine, right? So there has to be some other low level internal record fee.
Yeah, because it's Open GPU or Open AI is the first, and there's an AI a foundry, open source organization. They open up their the AI chipset. So that is the one that we build on top of it for our Open GPU. So the whole the graphics stack is going to be still Mesa, and then LVM Pi, and then on to the vectorized or matrix instruction or proprietary RISC-V instruction that do the rendering to the DDR and then pump it into the display controller. So that will be for low end only, because I have no idea about how ray trace. Yeah, graph it first because we need to see it. And for at least for our desktop here, for all our community, so that they can get familiar with RISC-V, we probably got to graph it first. I don't think it's first or back, first or second. And then for Tenstorrent, all the hardware they already have the stack equivalent to CUDA, but he tried it already. It's just a lot of work. So we still got a lot of work to meld it to NixOS and make it orchestral, able to scale onto different models and better performance. So far, I think data flow, we call it Tenstorrent, is a data flow design acceleration, very different from GPU as a media. So we can see certain model where 10 times better than NVIDIA. So that's why on those model, you probably can get 1/10 of the price of the market price offered to the market. So that might be the thing that we are focused to work on the AI side. So, but it's all open source. People can learn a lot more than CUDA. So on how the stack work on the data flow compiler. Okay, and then we always come to our RISC-V booth, then we can discuss more how you guys can contribute.
So another question. I think you got some demo about it, but people can go to your website and sign up to get some hardware.
Yes, definitely. We have a sponsorship program coming out. If your school, and then if you are open source project, for example, all the NixOS project, they were gonna get free hardware to port it, right? And then until they become some mature hardware, mature OS, that people can buy it and use it and do their own job and earn money out of it. Yeah, we have all the dev kit, for all these hardwares, and they will all open source and as upstream as possible.
But you have to be a student. What?
Excuse me?
You're saying you have to be a student to get that for free?
No. You have you do a project, contribution to Lex, or contributing to RISC-V, and anything that you can think of, or you learn something out of it, and you create a community out of it for advocate Nix, advocate RISC-V, then you are free to get the hardware. And do come up to the DeepComputing website and find out more. This